I have created something super cool recently, and I wanted to share with you that one because it has a lot of kind of uh, like challenging stuff, like a lot of architecture and not really trivial stuff, and I wanted to share with you. So in this app, which is basically a React app, I have a system that you can create a wall. Just don't get into the construction part that much. It's more about the front end and React. It's like when you create a wall, you can choose a material, and then like you can choose, for example, this block, and then insert. All right. The point is, I needed a system which you could explore material. And I'm going to share with you what I did in there and how does that work. So you see when I open this, drawer opens, and then again I can open a drawer on top of that. And this technique has been explained very well in another video. You can go to my website under the experiences, under the workshops section, I believe, and take a look at that. But what happens is we need a system that we can list materials, and in an appropriate section, we would look for that type of the material. Now you might say, okay, we have create a list of things, bricks, and put it there, and that would be fine, but it's not going to be really robust. And what happens if we have like more than 1,000 tools, which is very trivial for a construction project? Therefore, what I've done was I created this material explorer, which is this component relatively, like you can search or whatever, and then like maybe 590. And it's gonna very simply show that like what is selected, and then like shows the element, the image, if it has the product image, and then the sources like the suppliers, which is a little bit incomplete at the moment. But the major point is that we have something called material. So I have defined a material with an ID, name, weight, extends, and characteristics. Like these two things are the most important. Characteristics is like a object, or in this case, it's an array of object, which is characteristic, is that you say it has a trait and it has some data in it. So what does it mean? We say a material, for example, this Red Bull, we say it's a solid. It's like non-load bearing. So if I push it, it's going to be crashed, and has a color. So it has a set of traits, and it has a dimension also. Let's say a dimension is another trait. And instead of we define a product, a particle that is like a beton, or it's like it's a brick, in order to make it to work, like we provide a lot of materials, and the wall tool knows this is very compatible to put it inside a wall. So we need to create some characteristic systems based on the real physics. This is what I have done. So I said there is a solid, cuttable, dimension, load bearing, masonry compatible trait, which masonry compatible means you can place it in a wall, like anything which could be placed in a wall. And then defining like custom type of information package like data, metadata. And then we will go and create the material data on top of that, which is like putting all of the base materials and their hierarchy. This is the important point. What does it mean is when we have some material, as we mentioned, in the material object, it can extend another material. So what we do is we say this is a solid, and then we create a glass material which extends the solid. So it's solid and a glass, and then like other characteristics on top of that, and then add a dimension to it, makes it a real product. And then we put suppliers to it, who is where you can buy this product. What does it help is that you will have a solid material, which is a masonry, which is a concrete, and now we can create many different variants on top of that. Exactly what happened here. You see, we have a base Gazobeton, which is type of AAC material, and then it has a characteristic material kind AAC. And then we have something called masonry block element, which is the base material for the base Gazobeton. So it extends this one. So it tells us that the material AAC is cuttable, is masonry compatible, load bearing, and solid. And now we're defining a 59 by 24 by 24, which extends a base Gazobeton and has its own characteristics, which is a dimension. Therefore, we can place it in the wall tool. Now, in the wall tool, what we do is we need to go and select for, let me go to the Explorer, Material Explorer, and we need to say, when we are filtering all those elements, we want materials which are having a trait dimension. So it could be placed. Now, if we want to only pick the Gazobeton ones, we have to put like a cuttable, let's say, just for example. What happens is if I go back here, still I see them because they're cuttable. And then if I want a trait type to have a connector, then you see there is nothing coming up because this material we have defined and its hierarchy does not implement a trait connector. Therefore, if we modify this Material Explorer now to pass this parameters to it from the place which is being called, which is use, for example, use material picker, use material, I think I had it already. Yeah. And then instead of single select, I pass these parameters from here to that component. Then I can use this material picker to pick anything which is matching that area. Now in another tool, we will need to select the rebars. So we don't want to user be able to even see the brick system. Therefore, this kind of architecture helps a lot to solve that matter. And what we do is we have this function which would like check if every trait we wanted is available in the object and its hierarchies. So what we do on init is we go and as you remember in the data section, we are not having them like all in line. They are extending one in each other. So like 5 extensions happening. When we start, we go and resolve all of those characteristics and put it into a cache object. So then this kind of filter system, which is find materials with traits, would work perfectly. And now anywhere else, when I need to pick a material, I don't go and create a model or anything. I just go to say, I want this hook and then select a single material. And it could be extended to select multiple materials function that allows you to select multiple functions. Now in this scenario, we have extremely like kind of how to put it, versatile in a robo system, that if some other type of bricks come into the system, we don't go change code anywhere. We rather just go and create a new element, extend it from Gazobeton or extend it from solid, and then this tool automatically will know about it and would allow the user to pick and select it. Therefore, it makes this very easy. And let's do it very quick to actually not talk only. Let's say we have another block which is let's say 9 by everything, right? And then it's extending the base Gazobeton as well. And then I go here, import it, and I will add it here also to the material. Now, if I go back, let me see, I guess, did something very bad here. And yeah, so you see like it came here now. We have this 9, 1, and then I could create a wall with it. Like it looks a bit weird with sizing and all those things, but the system works very versatile, and that's what exactly you want in a product, which can be modified, or dynamically elements will be added to it. So if we ever export this kind of material information to the backend, front end is fully unaware of it, and by adding some filters or traits which it supports, then you can create any kind of material or product on top of that. Of course, this is for like extending a lot of things you can do with it. It's very basic, but it's important to put the base architecture very correct, very comprehensive, to support the software for a very long time. Thank you so much for your attention. That I hope if you're doing something similar, this video helped you to some extent at least. And see you later on another topic.